Okay, we're good.
You don't see the recording
I'm recording
message?
just my screen. I'm not recording through
Oh,
Zoom.
oh, right, right, okay. So today's meeting is meant to discuss chapter 3, section 3.3 and 3.4, right?
Yeah, we can go back to 3.3. We talked about that a little bit last week, but I don't think Reeves was here. Or maybe we didn't talk about it. I don't even remember.
Yeah, if I remember correctly, the last session wasn't last week. I mean, the last session, right? We just talked about 3.1 and 3.2. And then when we stopped, we said, let's try to take it two sections at a time. So we said 3.3 and 3.4.
Okay. Well, then I read ahead, so I feel good.
How far ahead?
I just read to 3.6.
3.6. Wow. So, okay.
I
Did
mean, I'm
you,
usually something of an overachiever, I must say.
but did you do any of the exercises?
No, none.
No. Notes?
Yes.
Okay, cool. What about Reeves?
No, I haven't done anything.
Not even 3.3, 3.4.
No, nothing.
Oh no.
Well, I mean, I had read it. I have read it at one point.
Uh-huh.
My book has markings in it, which means it's been read at some point, just not recently.
Okay. Well, so I mean, do we want to continue or do we want to postpone? Because I have a few questions that I'd like to ask, and I don't know, I would like as much input from everyone.
Why don't we try, and then we'll see what
We
happens.
try. Okay. Okay. Then I'll start with the one that is most pressing for me. So in the PDF on page 68, I was trying to derive equation 3.13 and I couldn't do it using the truncated product formula, which is just a few pages before that. Um, Specifically, it is on page 1 second,
It's on page 60.
60, is it? Yes. Yep, that one. And then before we even read the text, on page 68, there's actually a few errors here and there. I found out because I was also reading the errata of the book. Um, Let me see. Yeah. Um, how should I do this? Can I share on the chat the errata? And then I can tell you guys the page.
Yeah, I think we both have it, right, Reeves?
Mm-hmm.
Okay, so in the errata on page 22, formula 3.13, sorry, equation 3.13 has an amendment. It's just he forgot to put the probability of x equals x at the end. So everyone got my question? So basically, I'm trying to get the 3.13 and the right hand side. The way I did it was, so yeah, I got stuck because my answer was I had everything except for that condition x equals x. I should have saved my work, but I didn't. So sorry about that. But what I really would like is for us to work through this derivation together. If you guys are up for it.
Sorry, I'm trying to orient myself to the problem. This is coming from the formula on page 60?
3.13 is coming from page 60 because, it's from page 60 because you see that the last equation in the bottom of the page, the one that's not numbered,
Yeah, they call
the one
it
that has the multiplication, right? Yeah.
Yeah.
So apparently this is the generalization of the adjustment formula. So I thought if I just apply this formula, I should be able to get the right-hand side of equation 3.13. But I couldn't.
Okay, it might be helpful to start with drawing the DAG, right? So we have
Okay.
we have
Maybe you want to draw on the left-hand side, yeah. So you
Yeah.
have more space.
Here, and I can even put it down. Well, yeah, okay, I'll put it way up here. So we have U. Did they just write the DAG? I'm trying to go from the arrows. I think they wrote the DAG just right before, right?
I believe the deck is on page 66. Should be B.
Yep, okay. Okay, and so just to make sure that fits with the arrows, X goes to Z, U goes to Z. Oh no, I'm sorry, U goes to
It goes
X.
to Y.
Yeah, U goes to X and Y. Okay, yeah. So the question is, looking at the relationship from Z to Y, and so we need to block the path from.
Wait, I don't think we need to even think about this. We just apply the formula mechanically. Do we even really need to think about what things to block? Because I thought the formula will figure it out for
The
us.
formula involves the parents of Z though, right? So we at least need the DAG,
Okay.
right? So you're right. We don't
So-
need to. We're just sort of. I'm just sort of making explicit. We're trying to block this path around. right? We care about this path, and we're trying to block the one going around this way.
Yes.
But we do need to know Z's parents then, right?
Yeah.
Which
Let's
is
write it down. Yeah. So Z, the parents, call it pair. The parents of Z is just X. Do we agree? Yeah. Okay. And then the parents of X is U. Agree? Okay. The parents of U is nothing, right?
yep.
Just put a dash here. And then the parents of Y is Z and U. Agree? Okay. So yeah, we have U, X, Y, Z, we have everything here. Then now it's just a matter of applying the formula, I think. Shall we? Okay. So we want to know the probability of Y equals Y, given that we intervene on X. And Pearl says the do operator does that. So X equals X. Okay. Now, if we go to the formula for the definition of that, truncated product formula, it says that this should be equal to the multiplication I of P, the probability of Xi given P A sub I for all X, for all I, with Xi not in X.
Can you explain that to me? What do they mean, all xi not in x?
For all Xi not in X. I believe it means the complement of all the variables in X. What do you think, Reeves? Because this X sub I is referring to a random variable, and then it says not in X. X is another random variable. I feel that the logical interpretation would be the complement of the X.
So this is
Ideally, I would prefer him to have said the set containing X. I think that's what he's trying to say implicitly.
so it's everything in the set of that we're intervening on, because this is for multiple interventions, right? So it's everything in the set we're intervening on except the one variable we're talking about, the xi, the particular xi we're talking about.
In this case, we only intervene on X. I mean, this on the left-hand side, we're just saying that we're just intervening on X, and then this part here for all I with Xi not in X, it says to only consider all other variables that we did not intervene on. So it should be Z, Y, and U, I think.
Well, if I look at the formula on 60, on the left hand side, there's the do operator on x. So we're intervening on the set x, right?
Yes.
And so for all I with xi not in x, I'm assuming, if I'm interpreting you correctly and interpreting him correctly, we have a set, this formula is for a set of variables we're intervening on, right? The set of variables in X. Yeah, because right above there he calls it the intervention set X
Where?
on
The straight
on page 60,
dimensions.
right above the formula on page 60, the
Oh,
very last sentence.
yeah, we simply right now. Shut that one. Yeah. Yeah. So X is apparently a set.
It's a set of variables we're intervening on.
Yes.
And so that formula should simplify on the right hand side. It should simplify immediately to the fact that we're only dealing with one x, right? We can get rid of the i's because we're only dealing with one x,
Oh.
right?
So how would you write the next line? Because yeah, I'm not sure what you mean by getting rid of the I.
Well, if there's only one x, xi
Uh-huh.
doesn't really make any sense, right? So it's just, I mean, it can only be equal to one thing. So wouldn't it just be, then that means there's nothing to multiply out. So wouldn't it just be the probability of x given the parents?
I would say no, because to me, this statement means that we need to consider the I in the set U, Z, Y.
See, that's what's confusing me. That's where I don't quite get it. Adjustment for interventions that fix the value of a set of variable x to constants. We simply write down the product decomposition of the pre-intervention distribution and strike out all factors that correspond to variables in the intervention set x. So we introduce them to one.
So xi not in X means that get me the random variables that is not being intervened. And in this case, we have these random variables here, z, x, u, y, and we are intervening on x. So we strike out the x and only consider and only iterate over z, u, y. Z, u, y. Yeah. That's how I understand the formula.
I mean, it makes sense we'd want to think about those things, but my confusion's coming from the fact that even in our formula, I mean, we have the do calculus do x, and so we should be saying it should just be operating on the parents of x, right? Or conditioning on the parents of x, and not all other variables.
I think the answer to that question will depend on how, I mean, we will see the answer once we apply the formula.
So,
But right now,
what's the next step then?
Okay, wait. Before that, I just want to make sure that we all are on the same page. So when we say on the x here, this x here is referring to this x over here, right? Just color coding it. So in my opinion, the next step is to do this probability of, so I'm going to iterate over all the elements in this set here. So I have u, z, y, so I'll just do that. I'll follow that order. So probability of u given the parents of u multiplied by the probability of z given the parents of z multiplied by the probability of y given the parents of y. What do we think?
I'll let Reeves talk if he has something to say. Otherwise, hang on. I'm thinking through it.
Okay.
It looks good to me as long as everything else is correct.
Yeah. And we're only on the second step. The first step is how confident are you it's correct? I mean, if we misinterpreted this part here for all I with xi not in x, then yeah, you know, everything else is wrong.
I mean, I think it's confusing to try to put this in the language of set theory when it just sounds like for all variables that we're not intervening on.
Which is the
Isn't that
same
what
thing as.
That's what that for all I or all xi, that just means for all variables that we're not intervening on.
Yep, that's how I interpret it too.
Yeah, so I don't know why he had to use the like set theoretic language to get that across, where he just could have explained it in English.
Well, it's precision. I find the maths is the set theory approach is very precise.
Yeah, but our minds are as are
Yeah.
to deal with knots, like to think in negatives. Maybe he should have defined the set of variables that aren't being, it's the complement of the intervention set. So maybe he should have given that a name, or just said for all x in xc or x complement. Yeah.
Yes. That will have been clearer. I'm also going to, I want to say that this part here can be struck off because we are assuming that U is unobservable.
Yeah, I'm going back. Sorry, guys. I'm stuck on
Oh,
the first issue. So on page 60, he is going through the formula. He's giving an example using the graph on page 49. Oh, hold on. Maybe I'm an idiot. Hang on. WC1. Oh, never mind. I'm an idiot. Never mind. Okay, I was looking at the graph on 2.8 and he meant the graph 2.9 and they're like mildly different and it worked for half the formula, not the other half. And God, this book is just causing like aneurysms in my brain. So okay, so he does mean what you're saying, I think. Like now that I went through that example, he clearly is saying that for the variables you're not intervening on. So that I feel better about that. I agree with Reeves. It would have been helpful to just make that explicit. Okay, and then so why do you have? Sorry. P of U here is the parents of U.
P of, yeah.
Okay. Sorry,
P
I'm
is
with
the
you.
parents, U is the variable.
Okay. So it's U given the parents of U, Z given the parent. Yeah, okay. So I'm with you. Sorry, that makes a lot more sense. I feel good now. Took me a minute.
Then I want to say that we can strike this off because U is unobservable. What do we think?
Mm, I mean, the formula doesn't even make sense because it doesn't have parents either. So it would just
You mean for
reduce
you?
for you, yeah. So it would just reduce to the probability of you,
Yes.
and
There
then
was he did mention this in the chapter 1 where he talked about the multiplication rule,
so he says
something like that.
it's just by definition we just take out the condition.
Yeah.
Okay, I vaguely remember that. So the probability of you, can we just get rid of that?
I think we can, because if we assume U is unobserved, which we are, that's the point of the example. The cigarette, there's like some factor that's influencing smoking and cancer. Yeah, X is smoking, Y is cancer, Z is the tire buildup. This U is supposed to be some genetic thing. Okay.
Why do we need to get rid of it? I mean, like,
If
will it not fall out as we average over every value of u at some point?
If you're just
you don't,
dropping out, aren't you implicitly assuming that it's certain that its probability is equal to 1 if you're just canceling it?
okay, how about this? For this one, in the line 1, isn't it implicit that we only iterate over the observable variables? No?
I mean, whether we observe it or not is whether we can calculate the effect. But that doesn't mean that the effect isn't being modified by that variable, right? I have a feeling it's gonna drop out when we integrate over or iterate over all the possibilities. Yeah, integrate over them, right? When we average across all cases of u, it's gonna sort of fall out anyway.
Okay, let's see. Okay, then we are in agreement. We can proceed with this equals u. And then for the Z part, probability of, oh, I should use small letter because I am I'm not sure. Well, to be consistent, right? I'll use the same format as this right hand side. So I'll say U equals U. That's all. And then probability of Z equals Z, given the parents of Z, which is just X. So we have X equals X. And then the last one is the probability of Y equals Y, given the parents of Y, which we say is Z and U. And if we pause for a while and look at the answer in the errata, I don't think we're close.
That's an assessment that describes my life. It's not even close.
Wait a minute. Yes, we can write. Okay, so in equation 3.13, on page 68, there's a summation across x. I believe it's because he wants to marginalize over x. So, okay, that makes sense.
And I bet you this is where the u falls out, because if we are saying that we're in, oh no, sorry, the u is going to fall out when we introduce the do part of x, right? Like because you're doing x, um, you're marginalizing over all the parents of x, right? Am I making that up?
Yeah, I think you are.
I've learned nothing. That's what I can.
I mean, according to the truncated product formula, this is the adjustment formula. We don't need to do any summation. Yeah. So yeah, I think this is the part I got stuck. Except for the part I dropped the U because I assume it's unobservable, so we can ignore it. Also, another thing is in his answer, the conditional probability of y has z and x as the condition. But for us, we have z and u.
Okay, so I'm looking at. You guys make me seem crazier than I am. I'm looking at formula 3.6.
3.6. Page number?
59.
Oh, just on top. Okay.
Um, so essentially, we're marginalizing over the parents of z in that formula, right?
One sec. Given a graph G in which a set of variable PA exhibits the parents of X, the causal effect of X on Y is given by we are marginalizing over the parents of X. Yeah, Z. Yep.
So
PA equals Z. Yeah.
in this case, I think we have to apply this similar idea as the next step would be marginalizing over this is how the u is going to drop out. I just have this feeling that like this is where u drops out is when we marginalize over the parents of x here, which is just u.
Okay.
I don't know where that gets us though. Before we even start writing anything, I don't even know where that gets you.
I'd say one sec. Is there a way to scroll down on the whiteboard, or is this all we have?
You know what? I think what we can do is select this.
Uh-huh.
Uh-oh. And then we can move it up potentially. Let's see if that'll work. So I think all of this is undoable, but I'm going to erase what we have up here.
Okay.
And then I think we can now select everything here. Oops, if my stupid mouse will work.
Whoa, well done.
Now, I don't want to say I'm the online teacher of the year per se,
But you are saying it.
but if you wanted to say it, I wouldn't argue.
Okay, thank you. Then the next step would be to marginalize over you. Is that what we want to try?
Yeah, I don't know. What do you guys think?
I'd say go for it and see what happens. So it's going to look like this. Marginalizing. Yeah, I want to select and copy. Can I do that?
Yeah, I would think so, right? So you have the select on the left of your where you choose what like color you're writing in. Select is the option on the left.
Wait, I don't see select. I see eraser, arrow, stamp, draw.
I might have access to more than you have.
Because you're the
Or because I have an
boss.
updated version of Zoom. I know this could
Oh,
be
yeah.
part of the update. I don't know if you have the update.
Yeah, I'm not in the habit of updating Zoom. Could you please try, Zach? Copy, paste
Which one do you want to copy? The whole line,
the whole line, yeah.
including the equal sign?
Except the equal sign. Oh, you missed the Y.
It might not let me copy it anyway. Well,
No, does it work?
no, it won't let me copy it, but I can just drag it down.
Uh, okay, yeah, better than nothing. Okay, thank you. And then this would be, I'm gonna write it down here. This would be just probability of Z and I don't know how to justify this. But does it make sense to you guys?
Well, the way you justify it is through the law of total probability, right?
Exactly how.
Well,
I mean, by the law of total probability, it says that, yeah, everything sums to one. And, if you have a case that's mutually exclusive, like, let's say, the probability of x1 plus x2 plus x3, where all the x's are mutually exclusive, then, yeah, you get to one. But I've never seen one that has conditional probability in it. It's always unconditional. So that's why I'm unsure how does the law apply in the case of conditional probabilities. Does the condition get dropped out, or is it still supposed to be there? Like here, I assume the condition gets dropped out, but I don't know.
I'm gonna ask Reeves because he's been silent and he's the guy who's been spending all of his free time on probability.
Oh, no, I don't.
Used to.
Yeah. I mean, I don't, you have to have a partition. I don't know what the partition is. Like, because that's what you create a partition of whatever your sample space is. I don't know.
Well, it's U equals UI, right? It's for every UI in U.
Yeah, because we are summing over the U, so we are partitioning over U.
Okay.
I'd say U is the partition.
Yeah, I don't know how you get from that to that. I mean, because from the last one to the earlier one, if you
Which
were
one? Wait. Let me label the things. 1, 2, 3. Yep. So you were saying this from which one to which one?
if you were thinking about going from 3 to 2,
From 2 to 3, you mean?
no, I'm saying thinking back.
Oh, okay.
And then which, like if you partition, then you would also be, oh, be you'd be conditioning U, or Z would be conditional on U as well as Z. I'm thinking.
C will be conditioned on U as well as Y. So you're saying that Y should also, U should also appear here, right?
Yeah, it should look like it.
U equals U, right?
I was thinking, I mean, in my mind, that makes it look more like you're applying the law of total probability.
Yep.
So as I look at the formula 3.6, I mean he's marginalizing over the parents of X even as a group. I'm just trying to think about how he's even getting that. I mean, there's something implicit happening in what he's doing in that formula, right? Because he's doing what we're doing and he's saying it works. Right? Like if I look at his formula in 3.6 on page 59, if you showed me hold on. So the difference is we have it's all implied because here I'm going to erase this obviously, but here it's not x equals x, it's do x. Right? Or
Why? I thought do X only appears once here on the left hand side. Then on the right hand side, you don't need to think about do X anymore.
Yeah, that makes sense. I'm just thinking, why else can you? There's something implicit here about what's happening to Z when you write it out as do X, right? When you write do X equals X, that is the assumption that you're you're marginalizing over the parents of X.
Yes.
So it feels like there's something missing in my mind where like there's a gap where that's implying something that's not showing up in our formula.
Mm-hmm.
Does that make sense, that line of thought? That like there's something in our formula that's missing that's implied by do X equals X. Like
Yes.
there's already being marginalized over the parents.
Well, how about we do this? We apply 3.6 instead of applying the truncated product rule like we did before. We apply 3.6 and see where that gets us.
And then try to generalize from there.
Yeah, because 3.6 already has that summation in it, which is consistent with 3.13.
Before doing that, is there any other way to get from like formula 2, forget the summation, right? We didn't need the summation. Oh no, did we? Where did we leave off? We left off with just the probability of U, and then we added the parents in.
Yep. Yeah,
right?
that one.
So can you see when I highlight?
Yeah, I can see.
So it's just this
So
right here
you-
that we left off with.
Mhm.
So if we just go back and forget my suggestion of marginalizing over U, can we do anything with this before we give up on it?
Oh,
Like I had the one suggesting of marginalizing over U, and I'm not sure what else we had. I'm not sure if there was another suggestion.
oops. Whoa. Too far, too far. Oh no. So apparently you can't undo.
I have no idea what
Are,
just
are you
happened.
are you trying to do something, Zach?
Yeah, undo what you did, but it's not. You can't undo an erase. That's a shitty tool.
Oh no. Are you still trying to recover?
No, I'm not. I give up.
Let me try and press Control Z and see what happens. See, you can. Yeah. Oh, you are reversing time. Yeah. So I was going to erase the summation just to like, be clear that, we stop. Ah, damn it. Ah, yeah, some things. Zoom's favor is buggy. I can't, if I erase the bottom, it will also erase partially at the top. So let me just strike off so we don't get distracted. Yeah. So yeah, we expand line 1, equate, and then we get line 2.
We rewrite. Yeah.
And then we definitely need a way to eliminate the first term, probability of U equals U. And also we need to introduce the probability of X equals X term. And also we need to get rid of, in this term, the probability of Y condition on Z equals Z and U equals C. We need to get rid of the U and somehow put X inside there. I mean, could it be that, there's a mistake in the book that no one else caught? Or we are on the wrong path? I want to give up and try and apply 3.6.
Yeah, that works with me. I was also trying to work backward from 3.13, but it's not even clear.
Yeah, because he didn't show the any intervening steps. Yeah.
I do appreciate
Okay.
your confidence, Mohammed. You think you found a mistake in the book. I just assume I'm the idiot in the equation.
I mean, like, if what are the odds, of 3 people making the same mistake? That compared to the author making the mistake.
Well, let me tell you, the chance of me making a mistake is 1. So really, it's conditional on me making a mistake. It's really the same as the probability that 2 of you are making a mistake.
And also given, if you look at the errata, right, there's a lot of typos and also mistakes in the equations. So
Yeah.
You have to balance this out.
Are you applying base formula here? You're saying updating based on the number of mistakes already?
Damn it. Yeah, I think we can erase everything because the important thing is the deck, but we already erased that.
Alright, I'm just gonna clear
Yeah.
all.
Yeah, clear all. Let's quickly draw the deck again. X, Z, Y, K, variable, parent, U,
I'll be right
X,
back. I'll be right
Z.
there.
Okay. U has no parents. Parents of X is U. Parents of Z is X. Parents of Y is Z and U. Okay. From equation, we want to calculate the probability of Y equals Y, given that we do X equals X. Okay, and then so by formula 3.6, there's a summation here, and we sum over Z. Now this gets a bit confusing because we do have Z, PA, parents of X. So I'm going to say Z is the parents of X. What do you think, Riz?
Z is the parents.
Z in formula 3.6 is referring to the parents of X. So in Z, the thing being in 3.6, the thing being summed over is that variable Z.
Yeah.
And to me, it seems that it's referring to the parents of X in our particular instantiation.
Yeah.
Yeah? Okay, cool. We are in agreement. So probability of Y equals Y given X equals X. And then the parents of X, which we say is U. Oh man, this is terrible. The parents equals U. So X only has one parent, which is U. So I didn't have to do this. It's U. Well, at least now we got X in the conditional probability for Y. But it's missing Z. And also this thing should disappear. And also we should be summing over X, not U.
Well, so let me. Are we trying to do the same thing, but just using 3.6?
Yes. And
I don't think
before
I don't think that's gonna work because we're dealing with. Wait, are there multiple interventions going on?
no, only one, Z. We are intervening on Z.
No, we're intervening on X.
Sorry, yes, we are on X. I'm just writing down the answer that we should get, so that it's easy for us to work backwards, to visualize working backwards at least. Let me see if I got it right. 3.13 sum over x, y equals y, z equals z, x equals x. Yep, probability of x equals x. And then gonna say QED. Yeah. So if we apply 3.6, we get this. And then somehow we need to eliminate the summation of over u. And we have to eliminate u, then introduce x, and also the summation over x. And also we need to remove the u here.
And that, to me, this part right here looks like the law of total probability to me, right? It has a similar setup. Am I wrong in thinking that?
It is the law of total probability because, yeah, we are summing over u. Yeah, I agree.
So I'm wondering if there's not something more simplistic in the probability theory that's going to help us make this leap, right? Like, I wonder if we're just overthinking it, trying to apply all these complex formulas, as opposed to there's a simple sort of probabilistic relation that we're missing.
How about this? Assume u equals x.
That would help.
Yep. Oh no, almost works. we still have to replace this u with a z.
Not if it also equals z.
Brilliant, yes. Or
Mathematicians hate this one weird trick.
Yep.
So what is the relation that we're missing here? I mean, I'm just in my head. I'm just trying to think. Okay, so what is z equal? What are different ways we can write z? What are different ways we can write u? Different ways we can write x? What are some like equivalent ways of writing the probability of z? So we need to introduce it somehow,
z?
right?
Sorry, Zach. So you want to know? You think it's worth exploring how to rewrite z?
Yeah, because how else are we going to incorporate z into the model? Oh, and it might not be rewriting z; it might be rewriting x as a function of other things. But the idea is we know the causal graph is complete, right? That's by assumption, and we know that therefore that z can only be a product of u, x, and y. And even then, it's not a product of
I
y.
remember in chapter 1, the probability of z is equals to the probability of z given x.
For all x, right?
Sorry, no, wait, no, that's not what I meant. That's not what I meant. Does this ring a bell? It's equals to the probability of z equals z given x equals x, and then the probability of x equals x. Does this ring a bell?
I have to check my notes, but something like that. There might be something about x and y being independent there. I can't remember.
X and y being independent.
Well, no, I'm just thinking in general. There might be some condition that needs to apply, but
because I'm basing this based on the shape of the deck. Because I remember it says that if you want to find the probability of a particular random variable, just multiply it and conditioning it on all the parents. So Z has one parent X, then you can stop at X. Or if you want to include U as well, I guess we can also add U over here. Then this will be X given U. And then we have the probability of U equals U. But this is Z. And
I want to propose that we end now, and what we do is we use this as our homework assignment for the week. Because
Okay.
I think we're making some progress, like at least in a way, but I don't know that we're going to be able to sit here and get there right away. Like I think we might need to step away for a minute and regroup. At least we've been looking at this for an hour. What do you guys think?
That is true. Yes. I lost track of time. Yeah. We should stop here.
Yeah, why don't we come back to it next week though? We'll try to see if we can solve it over the week and put it in Slack. But I think there's some way to get there. I don't think it's a pure mistake. I think there's some relation, like what you've exploring up top there. There's some relation that we're missing that will help add in Z to this equation.
Okay. So we'll discuss this next week.
Yeah, unless we come up with a solution over the week.
And then someone shares it on Slack.
Yeah.
And we agree on the answer.
Yeah.
Okay. Sounds good.